In this video, we're going to begin to look at the calculus of polar coordinates. Now, they actually are a little bit easier than I think you would even expect with these two equations. To start with, we have x of t is t to the fifth minus 4t cubed, and y of t is t squared. And we're looking for the derivative, dy dx. Well, kind of like polar coordinates, which we've talked about before, the way we do this is we look for the derivative of y with respect to t, and divide that by the derivative of x with respect to t, and that will give us dy dx. So our change in y with respect to x comes out as a function of t, but that's okay. So we start with, what's the derivative of t squared? Well, it's 2t. What's the derivative of t to the fifth minus 4t cubed? It's 5t to the fourth minus 12t squared. And it says find the equation of the line tangent to the curve at the point 0, 4. Well, we always need two things, right, for a tangent line. We need a point and we need a slope. Well, the point we've got. The problem is, as we go to plug into the derivative to find the slope, we find out, well, we don't really have a t to plug in. We've got an x and a y, but we don't have a t. But we should solve it. Now, I've said earlier, I said in another video, that what you should do is you should say, okay, I know my x is 0, so that should be equal to my x equation. I know that y is 4, so that should be equal to my y equation. Pick the one you think is the easiest to solve. Start with that. Like I would pick the y equation. I would say, well, that means that t has to be equal to either 2 or negative 2. And I would go back and I would say, well, if I plug in 2 to the fifth is 32 minus 4 times 2 cubed, so 4 times 8. Yeah, it does work. If I plug in 2, that works in both equations. Now, if I plug in negative 2, negative 2 to the fifth is negative 32 minus 4 times negative 8. Negative 32 minus negative 32, that's also 0. Both of these equations work. So what that tells me is I'm actually going to have two tangent lines. And take a look at this graph that I just pulled out here, and you'll see that at the point 0, 4, there are two tangent lines. There's going to be one going this way. There's going to be another going this way. So it verifies it, okay, which is kind of cool. It's a little bit different. One of the things that's kind of fun about polar coordinates, makes it different than some of the other types of things we've dealt with, okay. So let's plug in 2 to my derivative. So 2 times 2 is 4. I'm just going to write this down to keep a note to myself. 4 over, plug this in, 5 times 2 to the fourth, so 5 times 16 is 80, minus 12 times 4, so 80 minus 48 is 32. Well, 4 over 32 is 1/8. So I have a tangent line of 1/8 x minus 0 plus 4. Well, if I plug in negative 2 to this thing, 2 times negative 2 is negative 4. The bottom, because it's t to the fourth and t squared, a negative is not going to change the bottom at all. So this slope is negative 1/8. So y equals negative 1/8 x minus 0 plus 4. And it was probably, once you saw the graph, you probably had a pretty safe bet here as you look at it that there was some symmetry. So, yes, it probably was going to be a positive and a negative, and the slopes would just be the opposites of one another. But kind of cool how that works out. So let's look at this one. Okay, finding dy dx, well, let's start the same way. We're going to do dy dt, which is just 6t, and we're going to do dx dt, which is 3t squared minus 3. Okay. Now it says find the equation of the line tangent to the curve when t equals 2. All right, well, we need a point and we need a slope. This time we have neither to start with, but it won't be hard to come up with. We're going to start with the point. I'm going to plug 2 into x to get the x coordinate. So 2 cubed minus 3 times 2, that's 2. Plugging t equals 2 in here, 3 times 4 is 12, minus 9 is 3. And then to get the slope, I'll plug t equals 2 in to the derivative. So 6 times 2 is 12. Let me just make a note of that so I don't forget what the numerator is. And then the bottom, 3 times 4 minus 3 is 9. Or 4/3. So my tangent line would be y equals 4/3 x minus 2 plus 3. Next, it says where does the parametric curve have horizontal tangents? Well, horizontal tangents mean the derivative equals 0, which means in our case the numerator has to be 0. 6t equals 0. So it's where t equals 0. Now this kind of depends. It says find where. It kind of depends what's being asked. I mean, it's t equals 0, but if you wanted that as a coordinate, of course, you should plug that back in. 0 minus 0, 0 minus 9. I would say that's a coordinate of 0, negative 9. Okay. Now, I also want you to think about this in terms of the two pieces moving, or this thing moving in both the x and y direction. If something has a horizontal tangent, that means it's not moving in the y direction, it's only moving in the x direction. So we need the dy dt to be 0, which is exactly what we did. We made the dy dt 0. So if something has a vertical tangent, that means it's moving up or down, but not in the x direction, so we need the x dx dt to be 0. So again, it all relates. A vertical tangent, of course, is where the derivative is undefined. So we'd make the denominator 0. So I would say 1 and negative 1. And again, it's kind of dependent on what you're being asked to do. I would want these as actual coordinates. So if I plug in 1, 1 minus 3 is negative 2. 3 minus 9 is negative 6. If I plug in negative 1, I get negative 1 plus 3, so 2 and negative 6. Now let's just pull out the graph here and see what this thing looks like. And you can definitely see these things occurring on the graph. At 0, 9, we have a horizontal tangent. At negative 2, 6, and positive 2, 6, we would have vertical tangents.